Hello friends, welcome to our channel Fundamentals of Engineering. You can subscribe this channel to explore engineering knowledge. So friends, we have started to discuss regarding the permutations, the topic which are there in the numerical aptitude. For the permutations, we have seen the part 1, part 2. Part 1 is related to get the different arrangements for the numbers with 0, without 0. And part 2 we have seen the problem based on the words. There we have seen the repeated letter, non-repeated letters, and the repetition of letters is allowed and repetition of letters is not allowed. In this part 3, the problem based on words in a second way, that we are going to see the always together type problems. So always together means when you are given the word, it contains vowels, consonants. So when the vowels are always together, when the consonants are always together, how we are going to arrange that word, that we are going to discuss in this session. So first of all, we have in the last part we have given you the homework for this part 2, that we have discussed that the repetition of letters is allowed and repetition of letters is not allowed, and repeated letters and non-repeated letters. So based on that, you have to solve this homework and you have to put the answer in comment box. So most of you have solved it. So if you have solved it, you can put your answers in a comment box. So first example was there, how many different ways the word function can be arranged such that the repetition of letters are allowed. So whatever the letters are there, all the letters can be repeated, and the repetition of letters are not allowed, means no any letter cannot be repeated. So how we are going to get the different ways? So first, when the repetition of letters not allowed, repetition of letters is not allowed, that we are getting the final answer. First we have to calculate the number of letters, 1 2 3 4 5 6 7 8 factorial upon 2 factorial, because n is repeated twice. So 8 factorial upon 2 factorial. So based on that, we know the factorial values. So based on that, 8 factorial value is 40320 and 2 factorial value is 2. So we are getting the answer when the repetition of letters is not allowed, 20160. if we divide this 40320 with a 2, and repetition of letters is allowed, we are getting what, how many letters are there, we have to take that power, and if there is any repeated letters, we have to divide with that factorial. So n is repeated twice, so 2 factorial we have divided. So we are getting repetition of letters 8 raised to 8, the value is 16777 You can get by using the virtual calculator, divided with the 2, we are getting the final answers 1388608. That is the final answer you are getting when we arrange the word function, when the repetition of letters are allowed and repetition of letters is not allowed. Second example, we have seen the engineer word, how many different ways it can be arranged. Engineer word, how many different ways it can be arranged. So first you have to count the number of letters, 1 2 3 4 5 6 7 8. 8 letters are there. So possible arrangements we are getting 8 letters, that will be factorial we have to take. So 8 factorial upon, there are repeated letters are there. Which one repeated? E is repeated thrice, we have seen 3 factorial, and n is repeated twice, 2 factorial, 8 factorial upon 2 factorial. So 8 factorial value we are given 40320, 3 factorial value is 6, 2 factorial value is 2, and there we are getting the answer 3360. This is the homework answers. Now we will see the actual part. So we have seen the types of numerical. First part, in the first part we have seen for the numbers, and in the second part of the this permutation, we have seen the word type problems. Repeated and non-repeated letters, repetition allowed and repetition of letters is not allowed. That we have seen in the second part. Third part, we are dedicated to always together. So today we are going to see the third part, always together in word, second part. So which one is always together? When the vowels are always together and consonants are always together. And there are some examples based on that. Some letters are underlined, so other letters are underlined or marked. Based on that, we have to arrange that letters. So today we are going to see the arrangement of the words when vowels are always together, consonants are always together, and other letters which can be underlined or marked when they are always together, how we are getting the possible arrangements. So friends, you are getting all the points. If yes, put the comment yes. Before starting, hope you are getting all the points what we are going to discuss today, always together type problems. You can comment yes in the comment box. You can give in the chat box as yes. So always together type of problem we are going to discuss. So before that, I humble request to all to take the screenshot of these factorial values. In the part 1 you have taken, part 2 also you have taken the factorial values screenshot. So those who are new in this session, they can take the screenshot of these factorial values, because these factorial values you are required whenever you are calculating the answer. So take the screenshot of these factorial values. If you have taken the screenshot of these factorial values, put your answer or put your confirmation in chat box as yes. So you have taken the screenshot, hope. Now we will see the actual problems. So in the words we have seen we are going to see the always together type 3, that how many different ways the following words can be arranged when vowels are always together. So first understand how many vowels. So before that, in our English we are having 26 alphabets. So in our English language we are having 26 alphabets. Among that 26 alphabets, A, E, I, O and U, these are the 5 vowels. These are the 5 vowels, and remaining 21 are consonants. Remaining 21 are consonants. So first remember this one. How many? 5 vowels are there and 21 consonants are there. Now this word, that garden word, we have to arrange such that the vowels will come always together. So among this garden word, how many vowels are there? You can see A is there and E is there. So A and E, they will be always together. So these are the 2 vowels present in this word garden. A and E, they will be always together. Now remaining are G, R, D and N. These are nothing but the consonants. These are nothing but the consonants, and with these consonants we have to arrange these 2 vowels in a such a way that this will become always together. So how we are going to arrange? Now there is a possibility that G, R, D and N, in between that we can arrange these vowels. So this vowel A and E, they will fix at this position 1, or they will come in between G and R, this is second position. They will come in between R and D, that will be a third position. They will come in between D and N, that will be a fourth position, or they will come at last, this will be the fifth position. How? You can see here. A E G R D N. So that is the first position. Then we have seen G A E R D N, that is the second. Third, we have seen G R A E D N, that is the third. Fourth, G R D A E and N, that is the fourth we are getting. In the first, in between G and R, in between R and D, in between D and N, or they will come at G R D N A E. So you can see the AE is always coming together. Two vowels AE always together, right? So now here we can do the possible arrangements, of these places with a 5 factorial ways, because these are the 5 different places we can arrange this AE word, AE letters we can arrange. So we are getting 5 factorial ways we can arrange. Now which letters we have to arrange? These vowels we have to arrange. So AE we can arrange EA. So in between that we can arrange. So these two letters or A and E vowels we can arrange with a 2 factorial ways. So possible arrangements what we are getting? 5 factorial, because 5 places 1, 2, 3, 4, 5. So 5 factorial into 2 factorial, because we are having 2 vowels. So 5 factorial value is 120, 2 factorial is 2. So we are getting, what is the value? 240. So these are the possible arrangements we can get. These are the possible arrangements we can get when from this letter garden, from this word garden, we kept vowels as always together. Vowels as always together. You are getting all the points? If you are getting all the points, comment or put your answer in the chat box as yes. We will see the another example when the vowels are together. Now there are repeated letters, that's why I have taken this another example. So now 1, 2, 3, 4, 5, 6 letter word. In that how many vowels are there? A and E. Again A and E, these are the vowels and they will come always together. They will come always together, right? So now remaining how many are there? P, R, K and R. These are the consonants. These are the consonants. So how many places will get when where this A will place? P, R, so sorry, here is the K and R. So how many places? First, second, third, fourth and fifth. First, second, third, fourth and fifth. So 5 places. So arrangements we are getting 5 places that can be arranged in a 5 factorial ways. The possible arrangements into how many? 2 factorial, because 2 vowels. But keep in mind here we are having the repeated letters. R is repeated twice. So you can see here R 1 and 2 times. The R is repeated twice. So whatever the possible arrangements we are making, there we have to divide with a 2 factorial, because R is repeated twice. So how many number of times the repeated letters, we have to take that factorial. So 2 factorial, that we have divided. So how we are getting 5 factorial? 1, 2, 3, 4, 5. 5 places, 5 factorial upon 2 factorial, because R is repeated twice, 2 factorial into these vowels, 2 vowels that can be arranged with a 2 ways in a 2 factorial value. So 2 factorial and this 2 factorial will be cancelled out, only remaining 5 factorial. So we know the 5 factorial value is 120. 5 factorial value is 120. This is the final answer. So the Parker word can be arranged in a such a way that when the vowels are always together, how many different ways? 120 different ways we can arrange. 120 different ways we can arrange. So this is regarding vowels. Now we can see the consonants. Consonants are together. So hope you understand the vowels are together. Now we are looking towards the consonants are together. So consonants are together means whatever the vowels are there. How many vowels we have seen? A, E, I, O and U. A, E, I, O, U. These, in between these vowels we have to arrange the consonants which will be always together. So from this word resign we have to find out how many are consonants. So consonants are R, S, G and N. So these are the consonants. These are the consonants which will be always together when we are doing the arrangements. And in between vowels we are arranging these consonants. So vowels are there, E and I. These are the vowels. So same we have seen in the vowels that we have to do in the consonant, but we have to arrange that consonant there. So possible arrangements E and I. So first place that will be coming, second, third. First, second and third. How? We'll see here. R, S, G, N, E, I. That is the first position. Second, in between E and I. R, S, G and N and I. Second. Third position we are getting at the last. E, I, R, S, G, N. R, S, G, N. So possible arrangements, how much we are getting? Possible arrangements. In this way we have to arrange this resigned word when the consonants are together. How many places? 1, 2, 3. So 3 factorial. Now we have to check whether it is there in repeated. No, there is no any repeated. And remaining are consonants 1, 2, 3, 4. These 4 consonants that can be arranged with the 4 factorial values. So tell me what is the answer for this? What is the answer for this? 3 factorial into 4 factorial. You can comment in the chat box. Three factorial into 4 factorial. So what is the answer? You can give in the chat box. 3 factorial value is how much? 3 into 2 into 1. And 4 factorial 4 into 3 into 2 into 1. So 3 factorial value so what is the answer? Possible arrangements we can do when the consonants are together. 3 factorial into 4 factorial. What is the answer? 3 factorial value is how much? 6. 3 into 2 into 1, 3 into 2, 6 into 1, that is 6. 4 factorial value, 4 into 3 into 2 into 1, that we are getting 4 3s are 12, 12 2s are 24. So 6 into 24, what is the answer? 24 into 6. So final answer you can put into the chat box. You can put your answer in the chat box or in the comment box. I will keep that as it is. Your answer in the chat box. We will take the another example. We will take the another example So how many different ways the following words can be arranged when the consonants are always together? The word is require. So first find out how many consonants are there. So consonants are there R, Q, then R, and these three are there. R, Q and R. Remaining are vowels. So these are three consonants. These are the three consonants. They will be always together. They will be always together. R, Q, R. These are the three consonants always together. So remaining are vowels, which are E, U, I and E. These are the vowels. So possible arrangements there we can do. At the first place we will get these consonants E, then in between E and U, in between U and I, in between I and E, and at the last. So possible arrangements 1, 2, 3, 4 and 5. So arrangements will get. So how many different ways we can write? So arrangements 1, 2, 3, 4, 5. So 5 factorial. Now see, is there any repeated letters? Now you can check here, E is repeated twice. E is repeated twice. So we have to divide with the 2 factorial because E is repeated twice. Into how many vowels are there? 1, 2, 3, 4. Vowels are over. Consonants 1, 2, 3. 3 consonants, 3 factorial. Now see here, is there any repeated letter? R is repeated twice. R and R. R is repeated twice. So that will be a 2 factorial. So 5 factorial upon 2 factorial, because these are the 5 places. There we can arrange these consonants and E is repeated twice. That's why we are divided with a 2 factorial into 3 factorial, because 3 consonants we can arrange with the 3 factorial ways, and we are divided with the 2 factorial because R is repeated twice. So 2 factorial. So 5 factorial value is 120, 2 factorial value is 2, 3 factorial value is 6, 2 factorial value is 2. So what is the answer? 60, 2 3s are 6. So what is the answer we are getting? 6 3s are 18 and 1 0. 180. That is the possible arrangements we can do when the consonants are always together in the word require. In the word require. Are you getting all the points? If you are getting all the points, put your answers or you can comment in the chat box as yes. Hope you are enjoying the session. If you are enjoying the session, you can like the session and you can comment and you can share with your friends those required all the points. The next, other words. Other words or underlined letters are always together. So these type of rare problems you will get in the exams. These are the rare types of problems. So first they are given the mark or underlined letters and we have to keep that underlined letters together. So now here they are underlined GINEE. So we are not focusing about the consonants and vowels. Just you have to see which are the underlined letters. So G, I, N, E and E. Always write into the capital letters. So we will not make any mistake. So G, I, N, E and E, these are underlined and they should be always together. They should be always together. Now remaining are E, N and R. E, N and R. So E, N and R. So these 5 underlined letters we can arrange with this first position, in between E and N, in between N and R, and at the last. in at the last we can arrange. So possible arrangements, we can get how many places? 1, 2, 3, 4. So 4 factorial. Is there any repeated? No, there is no any letters repeated, so we can't divide with anything. Now which we have to keep always together? These 5 letters, 1, 2, 3, 4, 5 letters. 5 letters we can arrange in a 5 factorial way. But here E is repeated twice. So here E is repeated twice. So we have to divide with a 2 factorial because E is repeated twice. So 4 factorial value is 24. 4 factorial value is 24 into 5 factorial value is 120, divide with a 2. So 2 12s are 24. 12 into 120 we are getting 1440. So these are the possible arrangements we can get when the engineer word in that GINEE are underlined, and these are the possible arrangements we are getting. Hope we are getting all the points. So here we have seen the vowels are always together and consonants are always together and other letters are always together. Now this is for your homework. The word is creator. The word is creator. We have to do the arrangements when the vowels are always together and consonants are always together. I hope you will get all the points and you will answer for this example, homework example. You can put your answers in the comment box. When the vowels are together, when the consonants are always together, how many different ways the creator word can be arranged. So in the next part we are going to see the type 4 when the vowels consonants are never together. Vowels consonants are never together. For up till then, stay connected and don't forget to subscribe your channel, your own channel, and stay connected. Click on bell icon to get more notification. You can share this content with your friends as we are discussing with regarding the GATE examination and other technical and non-technical examination. Hope you will getting all the points. So here we will stop. Thank you for the listening. Thank you very much.